Hello, I'm going to be talking to you about choosing a degree program that is right for you. Now, I know we're all faced with some very interesting paths that we can now choose. That we're finishing high school, or maybe you're in junior college and you're deciding, what should I do? What may I pursue degree-wise? And so I'm going to spend a little bit of time talking to you about that. So selecting a degree, that can sometimes be a rather big decision for you. And it can be very broad in terms of the scope that you decide to do. You could be pursuing a bachelor's degree or bachelors of arts, or maybe you decided to go on further and get a master's, or maybe a PhD, or maybe you'll use your degree to get a medical degree, or maybe you finish high school and you decide to go into a technical field, and all these are good decisions. But if you decide to select one of these, this is going to be an interesting path that you choose, and there's so many choices that you can make. And if you're a little confused right now, I would say don't feel bad at all. And as you can see here, 21% of first year students, when they go into college itself, really are uncertain about what major they should actually have. And I knew many people that when I went to school, they didn't really know what degree they wanted or where they had wanted to end up. And I can tell you that even for myself, that was the same. And if you go and look a little bit further, 36% of those decided to pursue a different degree. So once you made one decision, you may change your mind along the path. And that is definitely true. I know that when I first went to undergrad, I thought, I'm going to pursue a medical direction, maybe go to medical school. That was something my grandfather wanted me to do. But as I got into the program and started doing math and other areas that were involved in pursuing this, I decided I'd rather be a chemical engineer than any of those other ones. So this was the path that I took. So it can be quite different for all of us. And so I'd just say, don't be so afraid of that path. So when you're selecting a degree, what college major should you choose? And colleges change course numbers over time. You may have to retake a course, or maybe you might lose some credits if you don't declare a major. But the good thing is that there are people at at all universities, really, that when you come in and you make a transition into it, you will you will have help along the way, and you won't be all by yourself. But I believe the first biggest step that you really must do is reach out to others so that they can help you in that path that you may take. So that's really important. Along the way, must show some satisfactory progress. When you're here, that means you need to make sure you're maintaining C's as you go along the way, or you may lose funding, or you put yourself in academic probation, and that's a little bit daunting sometimes. And you need a degree to take a required course to graduate. So there's decisions that must be made along the way. And as I said, there are people at all universities that are there to counsel and try to help you, both within the department and outside the department that you may have chosen. And they'll help you make decisions. In fact, there's even a test that you can take that kind of helps you understand that. And as I say in the end of here, without a degree plan, there is no stopping point, but a lifetime learner, not a lifetime student. So that's really important to maintain, right? Some people go on to school forever. That's fun, but at some point you have to make a decision. Now, when you're selecting a degree, there's a difference in what you may do. So if you decide to get a Bachelors of Art degree, these are liberal arts. These are non-STEM degrees, so science, technology, engineering, mathematics based. These are not them. So you could get a degree in education, right? Go on and maybe teach in high school or kids, any of the grades K through 12, and there's absolutely nothing wrong with that. It's a great path that you can take. English, English, usually you're taking that because you love to write, or perhaps you may want to move on and become a lawyer, right? But these are things that you can take. Humanities, languages, literature, music, social studies, these are all things that are available to you if you do a Bachelor's of Arts. If you do a Bachelor's of Science, then it's going to be more scientific based in terms of mathematics, physics, chemistry. These are things that are going to fall out of this. You would be involved in things like, if you're interested in it, computers, or computer science is going to have some math based within there. And in the engineering fields, which are many, and as I said, mathematics and physics. So if you're looking at selecting this and within a department, as an example, Bachelors of Arts, let's say you chose a department of college, and let's say it was education, human development, liberal arts. If you're choosing liberal arts in that particular area, then your BA degree may focus on social studies, humanities, music, or fine arts. A Bachelor's of Science degree, life science, mathematics, engineering, and physical sciences. So Bachelor of Science, again, if you chose a department or college, let's say you chose the Department of Agriculture, then that's going to be specific in things that you do, or architecture, or business, geosciences, life sciences, or engineering, as I mentioned. So to kind of look at what these liberal arts touch on and what you may do, liberal arts, Bachelors of Art, these degrees right here, if you're involved in music, right, you're going to learn about the fundamentals of music, instruments, voice, classics, theater, foundational information is what you'll learn. English, writing, literature, classics, communication, trying to enhance these things that are needed. Social studies, history, political science, government, human development, communication. You can become involved in journalism, media, international studies, could be other areas if you got into languages. If you become involved in Bachelors of Science, these degrees, as I said, are STEM-based, and they have different areas. So they would touch on things as we talked about a little bit earlier: biology, geoscience, engineering, computer science, business. And let's say you were really interested in business field of this, and that means that you'd be involved in things like management, finance, marketing, accounting. And as I said, computer science, that would mean coding. So there's logic that's involved in here, game, network programming. So there'll be a range of different types of areas of math that you would use here, primarily. Well, we'll just leave it as there. It'll have a little bit of calculus in some of these solutions, but some will be algebra and matrix resolved into how you solve things. Biology, it'll be microbiology, zoology, lab, and as most people use, this is a path to get into medical school. And geosciences, geology, geography, meteorology. So if you want to be a weather forecaster person, that would be something you might do, or even environmental. And if you're looking at engineering, it's kind of funny. I always laugh when people talk about their experiences being an engineer, or someone saying, assuming that all engineers are the same. Well, unfortunately, those are not true. Engineering is a very broad category that you have in things that you may do. So if you're looking at engineering, there's material science and engineering. So you may be heavily involved in metals or ceramics, understanding phase diagrams, understanding how you'd utilize these materials into structure. So it's very cross-disciplinary in this area. Civil engineering, you can look at transportation, bridges. Professor Aylett, who spoke a little bit earlier, or speak a little bit later on to you, he'll talk about those areas. It could be electrical engineering, so how circuits are created, how you store energy, how you move energy, how it's created, etc. There's very foundational things that electrical engineers do. Industrial engineering, very broad area. Mostly you work in industry. If you're industrial engineering, understanding how to make processes more efficient. Mechanical engineering covers all sorts of different areas, from making golf clubs to designing cars. It's just incredibly broad, this field. Aerospace engineering, we're all familiar with the space shuttle. These are some people that would be involved in that. Biomedical is a relatively newer area where it takes in combinations of different areas of engineering as well as different sciences together to look at things such as biomechanics, where you're looking at prosthesis, or maybe how you would create tissue engineering. So it's very different. Chemical engineering is also very broad. I could talk all day about this one, but chemical engineering also has several different dimensions that are associated with that. And computer science is the same. So many different things that you can do within a Bachelor of Science in Engineering. All good things. So if we're looking at some of these in a little more detail, these degrees, since I'm an engineer and it's my job to talk to you and hopefully help you understand that engineering is incredibly broad. Mechanical engineers, here's an example. They're working on jet engines. They apply the principles of mechanics and energy to the design of machines and devices, and this is a great system right here. You're looking at you take entropic balances of energy, as well as so you're looking at entropy and enthalpy together with each other to make this thing work. But for propulsion, it's a very interesting area of field. Um, Mechanical engineers also work on devices that move, includes thermal designs as well as high vacuum air conditioning systems, just moving of fluids, moving of energy. These are things they do. They do vibration analysis. So if you're as an example, right, you'd have mechanical engineers be involved in some bridge design as well as with civil engineers, but vibration analysis is something they work on, mechanics of that, lubrication, gears, bearings, how things move, very dynamic field that they're involved in. Manufacturing engineering, you can see robotics here, and there's a Burger King bag there, so I'm pretty sure nobody wanted it there, but it is. But it covers all sorts of things. So design and manufacturing facilities for product development. I know when I worked for 3M, they wanted to go to more robotic system where they were making respirators. And so we had manufacturing engineers and industrial engineers and mechanical engineers involved in the process development of a primarily a robotic system that would allow you to make respirators that were very hand-driven before. But it deals with all sorts of areas: physical plant layout, existing machines, and how to build new ones, as I just gave you an example of. The balance between owning a device and renting a device or a facility, purchasing non-producing facilities and equipment, packaging, and shipping of materials. So it's very broad in what one would do. Industrial engineers are also involved in all sorts of different processes, design of manufacturing facilities for products themselves. I know I met several industrial engineers when I worked for 3M with my BS, and 3M highly values them, and they have an important role within the scope of engineering. They deal with things such as physical plant layout, existing machines and new ones, the balance between owning and renting the facilities, purchasing and non-producing facilities, equipping, packaging, and shipping. So there's quite a broad range. Now, as I mentioned, electrical engineers are involved in so many different areas that I really believe are truly interesting. Motion of electrons and metals, this is how you move information, store information. Work is focused on layer electrical systems, motors, generators, electrical circuits in buildings, power transmission, electrical generation plants. So they're involved in multiple things. And as you can see, they're measuring some resistor here. And of course, the color code means something. And for me, as a chemical engineer, I'm not really sure what the code corresponds to, but it tells you something about its capacitance as well as its resistance. So it's an interesting area. Computer engineering, this is one idea of it. Designing organization of computers, hardware, software. Who is the largest consumer of computers today? Well, it happens to be this is a good question for you to go back and look at that. And it's also used in the automotive industry. So this is a very huge area. People are using computers all the time to make decisions, to solve things. For animation, it's very, very broad, what they're involved in. And of course, civil and construction engineer. Civil engineers are very rewarding field to be within. It allows you to do so many different things. You plan, design, supervise facility construction from public to private sectors. Projects that you work on are very broad, from space launch facilities to dams and airports, irrigation ditches, tunnels. I remember one of my neighbors, when I lived in New Mexico, he was a civil engineer, and they were trying to decide how to build a tunnel that allowed you to go from one island to another island. And they're involved in doing that, and they had to basically be like Tetris, and they had to figure out how you'd bring tunnels down, or big, large conduits of concrete down in the middle of the downtown center of the city. And they had to do that in a very efficient manner, and they're involved in doing that. And this is what civil engineers do. They do a lot of interesting areas, big projects to small ones. And as I mentioned, biomedical engineers, prosthesis, here's one right here looking at trying to replace the cartilage and reface the surface of your femur, right? The ball joint between the lower leg and upper leg. But they're involved in all sorts of things. As I told you, they're a bridge in between physical and life sciences, and they try to work on identifying and solving medical and health-related problems. And if you look at this, they're involved in really three primarily areas: bioengineering, mechanical engineering, which is the example right here, or clinical engineering, where you're involved in the clinic itself, working with medical doctors and how they're solving different areas, such as tissue engineering. And automotive or mechanical engineer, here's an example, right? Design and build vehicles. Here's a little small tractor in Japan that they designed. Bulldozers deals with engine design, structural design, tire design. It's all sorts of areas that they may be involved in. Aerospace or astronautical engineering, flight in Earth's atmospheres. Specialized work areas may include aerodynamics, propulsion, control, structure, how you design and balance these things. It's not a simple area. This really focuses on fluid dynamics, which we refer to aerodynamics. It's just more specialized in this areas. And if you go further beyond our normal stratosphere that we operate in, environments not on the Earth, then you're talking about specialized areas where propulsion and cryogenics are a big deal. Materials and navigation while you're in space, thousands of miles away, and how do you get from one spot to another and then have it return is a big deal. Dealing with cosmic radiation, gamma radiation, and then of course the thermodynamic and huge differences in temperature drop that exist out in space. This is some of the things that they're involved in, which I think is very, very interesting. Or maybe you want to be an agricultural engineer, right? Where you're involved in all sorts of different spaces. It's a blending of engineering, of soils management, environmental control. These are all things that are associated with being an agricultural engineer. It has 5 specialty fields within here, one dealing with soil and water, other food, power, machinery, engineering, how you move things around, right? Structures engineering, so large spaces, electrical power generation and engineering. So it's very, very broad. And, I have a little picture down here of the Inca. They were, for them to be able to live where they did and be able to have such a successful balance between living in arid areas and very high elevation, very amazing. They were able to do some interesting things, balance between when water would be able to absorb energy, then when it became cold at night, heat would rise and basically keep plants alive and keep them from freezing. Just interesting area, but this is things that they did to terraform where they were to be able to survive. Architectural engineering, beautiful designs. I think it's really a balance between art and engineering, structural engineering. But they work on architects focusing on structural integrity and safety and design, making some very interesting balances that can balance with nature, harvesting wind as well as harvesting solar energy. Structural engineering in this field are very similar. The main difference is they're highly concerned with what is aesthetically pleasing to the eye, so they balance this art. So it's a very interesting area, a very difficult field, but as I said, very interesting. Chemical engineering, as I said, I could talk a very long time about this, but they deal with matter, how you convert matter into materials, chemicals. This is some of the things that we teach you how to do. We're interested in balancing and doing these things by using chemistry, physics, and math to be able to design such things. So we're responsible for new and improved products and processes, and it's very broad, from reactor designs and chemicals rocket fuels, energy, policy, medicine, plastics, textiles. It's an incredibly broad range. And as these little pictures show you below, we look at transforming a raw material into something that may benefit society in some manner. And that's what we're involved in doing. So, an important field. Chemical engineers also must qualitatively understand chemistry, biology, and physics to design useful processes while considering economics, energy, environment, safety, and other concerns that may come along with that. So if you have something in the laboratory, let's say a biologist or a chemist are working in a lab and they design something, well, chemical engineers then look at that and look at the chemistry behind that and the physics that may be associated with this, and then design something that can then be scaled to very large, energy efficient, safe ways in which to produce that. This is what we're involved in doing. Some chemical engineers are involved in looking at the fundamentals between biology and math and enzymatic engineering. They may model metabolic pathways in order to better understand microorganisms. So that may be for chemical or fuel production, enzymatic engineering, right, to make ethanol or maybe some other fuel, or maybe it's pollution remediation. Apply nature's designs to engineered systems to increase process efficiency, right? So maybe looking at how nature may convert electricity for photovoltaics, right, to how to improve upon that. And then, as I said, designing new drugs, manufacturing methods, and delivery devices that go along with that. If we continue with this, we're also involved in fossil fuels, biofuels, solar power, fuel cells, energy storage, very broad range of different areas. And if you see right up here in this upper corner, right corner here, you see what look like giant green test tubes. And that is actually algae. And what they're doing in this particular area is they're allowing CO2 to go into there to be able to capture CO2 that's produced from some process, right? And from there, they can take the algae and then convert that into a fuel. So you're actually making a positive impact of CO2 in the environment. And right now, if you want to talk about viability, they're actually using this idea with ExxonMobil right now, where they'll take their flue gases and gases that are being produced and go into a liquid media to be able to capture the CO2 efficiently, to then be able to use at some other point, or maybe even use it as a fertilizer to go back into the environment. So that's capturing the CO2 so that we're not adding CO2 to our environment. So controlling that. I think it's a great process to be involved in. So it's very broad. We also work in the area of trying to make our world more sustainable. So you have a huge range of different things you're looking at, from the upper left-hand corner of looking at how one would take plastics and instead of dumping them, putting them in the ground, do something with them and you reutilize them. Or maybe we're involved in the lower left-hand corner where you can see that somebody had been mining, maybe continuing to mine in this area. So we may be involved in trying to remediate the issues that come along with that. So if you look at that, you may not think about this, but all that beneath the ground doesn't see oxygen anymore. So that means it's been reduced and it's in its most stable state. But when someone digs into the ground and opens it up to oxygen, it now becomes oxidized, and oxidation then leads to these chemicals or metals becoming soluble in water, and that's not a good thing, and that then leads to destroying our ecosystems. So we're involved in all sorts of things. And then in the lower right-hand corner, you can see those are more than simply just tubes. They are reverse osmosis devices, and there are hundreds of them in place to be able to take salinated water and turn it into drinkable water. And so we're involved in all sorts of these different types of things. So when you're looking at that and you're thinking, where do people go in these degrees? If you look at the upper one, you see industry. And within industry, you see that industry employs the majority of us in high concentrations. So close to 50% or sometimes higher than that. Aerospace engineering, 63% of the people end up in industry. Civil engineering, it's 49%, so it's almost 50. You can see at self-employment, there's quite a high number. Over 10% of people decide to go into self-employment of their own based on their disciplines, or maybe they go off into doing education. So that's a smaller percentage that people go into education, whether it's high school education or it's college level. You can see that. And then some people will go into government. Sometimes I think maybe we have to have more people in the STEM disciplines go into government because I think it would help them. But anyhow, you can see that some people work for national laboratories or a national laboratory in general. But you can be involved in that. Some go into military. Some are involved in other government related. So state government, you can see civil engineers dominate that. And it makes a lot of sense if they're involved in making dams and bridges. It makes sense that they would be highly involved in that. So the point is that there's a lot of different areas where as an engineer, there are many fields that are available for you in engineering. Inside of an engineer's career path, employment, there are at least 7 career options once you graduate. As an engineer, you can go through the corporate ladder, meaning that you start your degree, you start your effort in a company, and within that discipline, you start running things, managing things, and at some point, the manager then becomes the manager of other managers, and then you head up through. So you transition from being technical to one that has much more programmatic control over everything that's happening there. Or as we said, you could be an independent person, entrepreneur, building your own companies. I've seen that with people that have done all sorts of different things, building their own companies. Military, government, engineering and social service abroad, professor or engineer, graduate work outside of engineering, or a mix of all of these options. And just as an example of graduate work outside of engineering, one of my colleagues, she was from France, and she came and we did our PhD together at Virginia Tech, and she went on to work for Bayer in Germany for several years. She came back to the U.S. and now she's way up in the corporate ladder of FedEx. And the reason they wanted to hire her is one of the things that you will learn as you go through this field, in the engineering field, is that we train everyone within the field to be very analytical in how we make decisions. And so you can see that making a logical decision has significant value. And FedEx wanted this woman there because she was not only technical, but highly organized in her thought and how she came to conclusions. And this is what you learn how to do when you're an engineer, which has benefits to multiple fields beyond that. So again, Bachelor's of Arts, Bachelor's of Science. People say, I'm not going to fully attest that this is fully true, but they say that, if you choose a Bachelor's of Arts, you're more of a right brain type of person. You're concerned with big picture, imagination, being creative, symbols, images. These are things that seem to drive you. I don't know if that's totally true, but this is what people will say. If you're a Bachelor of Science type of person, you're more left brain, a lot more logical. You like details, facts, math, science, order, patterns, practical application of ideas. You like that more so than the other side. Although I'd say there's mixtures that exist between both of these. So obtaining a degree, how long does it take? As the little baby's saying, when choosing a major, consider your passion and talents. I hope this is what you got out of this, at least part of it. And also that all of these are very interesting. And since I'm an engineer, I'm going to focus on talking about the engineering aspects of this. And this is why you saw so much about engineering. And you will spend money and time to get your degree. So think about that. So when you look at degree types, there are certificates. Certificates could last 4 to 24 months and varies by state. Or you can get your associates of art or a science. This might be 60 to 63 credit hours. Bachelors of Art or Bachelors of Science at a 4-year will be plus 60 to 63. Usually if you look at programs, these are normally closer to 100. So I'd say if you do that degree, a 4-year degree, you're going to do about 100 credit hours. So you're going to do about 40 more credits more than this. So as you can guess, about 2 more years worth of work. Masters or Masters of Art, usually the requirement is you go beyond this, but that class itself is maybe 20 more credits, and PhD, the same thing. So it's all interesting. So when you think about it, you can also think about, your degree and what one could do. And well, Richard Smalley was a Nobel laureate for discovering the buckyball. And as a Nobel laureate, you can say things and people will listen to you more so than someone like me. But he said there are top 10 things in the world that one needs to be worried about. Energy, water, and food are the top 3. Environment is number 4. And today we would say, because of everything going on, education, democracy, and population growth are very important to us as well. But these degrees will allow you to help people in a very broad range, right? So if you're talking about population, how does one grow as a population to be able to be in balance with the world as a whole, to be a good citizen, but also to maintain and preserve our precious resources that we have. In engineering or Bachelor of Science degree, Bachelors of Arts degree, these are all things that you can use that would help in different ways, whether it's legislation or actually physically doing it. And of course, if I were to point out to water usage, there's very little water that is potable in the world. And there are many areas throughout the world that really needs water, and water actually allows a civilization to grow and to thrive. And solving those issues is going to be very important in the future. Maybe you're involved in something like that. So with that, I'm going to stop here, and there'll be questions that you may have. And if you do, you can reach me at the email below and send them to me, ccornelius2@unl.edu. And I'd be happy to try to answer those questions by email for you. Or you can send some questions off to Gabe, and Gabe, of course, will reach out to me, but we'd be happy to answer any of those questions. So with that, I'm going to thank you for your time, and you'll probably hear again from me again. Have a good day.